Hello, everyone. First, let me introduce myself to you. I am now working as a tech lead in a big data engineering team in a famous e-commerce company at Silicon Valley. And today, I would like to share with you a special topic, the ACID properties and the CAP theory in the database system. Those are two very important and hot terminologies in the database. If you were interviewing with tech companies for software engineering position, then you will very likely be asking to explain the ACID property and the CAP theory. Before the ACID properties, I would like to spend some time to talk about the transaction. Transaction is a concept in the database system. By definition, a transaction is a unit of program execution that accesses and possibly updates various data items. So a transaction can contain multiple different steps or operations. So in the database, all the steps and operations between the begin transaction and end transaction comment are viewed as a single transaction, and which is indivisible unit. So since a transaction is indivisible, it either executes in its entirety or not at all. If a transaction begins to execute but fails for some reason, any changes to the database made by the transaction should be undone. So it means that the different steps in the transactions should succeed at the same time. For all succeed or none of them will succeed. This all or none property is called atomicity. The next, consistency. A database system should be, the consistency of a database system should be persisted before a transaction and after a transaction. If a database system is inconsistent before the transaction and after the execution of the transaction, the database system should also be in a consistent state. Here, the consistency requires not only the data integrity constraints in the database, such as the primary key constraints, foreign key constraints, or checking constraints, but also it requires that the constraints made by the logic of the application. I will show you an example of this consistency constraint. The isolation means that suppose that since the database system can support multiple transactions at the same time, suppose we have two different transactions, and the database guarantees that it seems to the user, to us, that the two transactions are running independently. They are running in a way like that the two transactions are not aware of each other. So they are running without any interference between each other. Durability means that if the transactions are completed and all the changes made by this transaction are written back to the database, then these changes should persist even the database system crashes or fails. So the ACID properties is a guarantee made by the database system, and the database system always promises to us, to users, all the transactions will be guaranteed to follow the ACID properties. So all the transactions will have atomicity, consistency, isolation, and durability. This will save us much of time to design and to use the database in our code or in our applications. So to make the concept clear, I would like to give you a simple example. Suppose that uh, we have a checking account called the account A and the saving account called the account B. And the balance of the account A is $1,000 and the balance of account B is $2,000. And we would like to transfer $50 from account A to account B. And this is a transaction that we defined by the user. And as you can see that the transaction is always defined by us, by the users or programmers or the applications. And if we defined that that multiple steps are a transaction, then the database system will always guarantee that this transaction will follow the ACID properties. So imagine that for this transaction, we will have several steps to complete the transaction. First, we need to read A from the database to a local variable. And then we need to subtract $50 from account A, and then we need to write back A to the database system. And again, we need to read B and add $50 to B and write back B to the database system. So in this application, in this transaction, we can imagine that besides the checking constraints, the primary key constraints, or the foreign key constraints, the application will also require another constraints of the logic, which is the sum of A and B should be unchanged during the transaction. So the sum of A and B should be always $3,000 before the transaction and after the transaction. This is the consistency promise. And atomicity. So we can see that there are 6 different steps in this transaction. And the atomicity means that all the 6 steps should succeed at the same time, or none of them all succeed. It can never happen that some steps succeed while the others don't succeed. So imagine that we have a failure point after the write of A back to the database system and before the write of B to the database system. Then if we have this failure point, then it will happen that the summation of A and B will never be $3,000 again. It will be, because A has only $950, B is still $2,000, and the sum of A and B is $2,950. Looks like to us that the $50 was destroyed by the database system during the transaction. So it is not consistent anymore. So the atomicity guarantee that all the 6 steps will succeed at the same time, or none of them will succeed. Suppose we have a failure point after the step of the write A back to the database system, and the remaining steps failed. Then the database system will need to abort all the changes by this transaction to make the database system in a consistent state. So durability means that if all the 6 steps succeed and the transaction complete and return back to the database system, then the changes will be persisted in the system, even if there is a crash in the system. And isolation means that since we can have multiple transactions running at the same time, then if we have a second transaction while we are running in the transaction T here, the second transaction is running at the time point when the write A is succeed, but the write B has not been succeeded yet. And at this point, the second transaction is trying to read balance of account A and the balance of account B and get the sum of A and B. Then it will see the balance of A is $950, the balance of B is $2,000, and the sum of A and B is only $2,950. So, which is not a consistent state for the database system. So this kind of read will not be permitted, will not be allowed in the database system. And in the next future presentations, I will also show you some protocols or some logicals that the database system implemented to guarantee for us that the ACID properties for each transaction. And briefly, I can tell you that the recovery system in the database will ensure the atomicity and the durability properties of a transaction. And the concurrency control system will make sure for us, will guarantee to us that the isolation property is followed by the database system for each transaction. And the recovery system will use the write-ahead log to ensure the atomicity and durability. And the concurrency control system will use some protocols like the log-based protocols or snapshot protocols to ensure the isolation property. I will talk more on them in details in the future presentations. So as a summary, that the ACID properties is a guarantee and is a promise made by the database system for us, for the users, that each transaction will follow the ACID properties. So this will save us much time in design or implement our applications. We can always trust our database that the ACID properties are guaranteed for each transaction. And we don't need to worry about the atomicity or durability or the consistency, or if we have concurrent transactions. Okay, so for the next topic is the cap theory. The cap theory stated that any distributed database can have at most two of the following three properties: the consistency, availability, and the partition tolerance. Let me give you an example to show you the three different terminologies. Suppose in a distributed database system, we have two sites, site A and site B. And site B is a replica of site A, which means that all the changes made to the site A will be copied to site B. So the consistency means that the two sites will have the same content. They are in consistent state. The available means that the system should always function at most of the time. And the partition tolerance means that the database system will need to tolerate the partitioning of the network. So in the normal time, we can always have a communication between site A and site B, but it may happen that the connections between the site A and site B cannot be established. So which is the failure of the network. And this failure of the network will cause the two sites are in the partition state like this. And in any large scale distributed system, partitions cannot be avoided. So as a result, either of availability or consistency should be sacrificed. Let me explain that. So if we happen a network partitioning between site A and site B, then if we would like to update a data item to the database system, because the transaction is submitted to the site A, and if we allow the updates of the data item, then it will happen that this changes of the data item cannot be copied to the site B because the connection cannot be established between A and B. Then these two sites are not in a consistent state. On the other hand, if we don't allow the updates to the data item in the site A, then it will happen that although the consistency of A and B are kept, but the database right now is not available. So we can see that in the situation of network partitioning, only consistency or availability can be guaranteed. So no database can both guarantee the consistency and the availability in the situation of network partitioning. In our example, as before, the banking account system, database system, which consistency is very important. However, in some other database systems, the consistency is not that important, such as the social networking database system, where the availability is very important. So in such database system, inconsistency is not as great a risk as in the banking account system. So a designer of such a system may decide that a user who can access the system should be allowed to perform updates on whatever replica are accessible, even at the risk of inconsistency. This kind of a property or this kind of system is called required by the base property. Like this, the basically available, soft state, and eventually consistency. And in base properties, the primary requirement is the availability, even at the cost of consistency. And updates should always be allowed, even in the event of network partitioning. Soft state refers to that each replica possibly having a different state, having an inconsistent state because of the partitioning of the network, but eventually all the replicas will become consistent with each other after the partitioning is resolved. This is the base properties, and this base property is always used in the database system such as the social networking, where the consistency is not at a great risk. Okay, so today I have finished all my topics, and I hope that those topics will help you understand the ACID and the CAP theory. And thank you, and see you in my next presentations in the future. So for the next presentations, I will plan to cover a course from the beginning to the end. I will cover the database system concept, and I'm looking forward to talking to you in the future presentations. Thank you. Bye bye.